Welcome to this lesson where I will review recursion. And for those of you who are new to recursion, then this is your introduction. So a recursive function is simply a function that calls itself during the solution of whatever problem the function was written to solve. So to introduce recursion, I will use the idea of a factorial. So if you recall from your algebra course, that a factorial is n factorial, n could be 4, is simply 4 times 3 times 2 times 1. Okay, and we know that 1 factorial, or any integer less than 1 or less, the factorial is 1. So the factorial of 0, 1. The factorial of -1, 1. But anything over 1, then you simply need to say n factorial is n times n minus 1 factorial. All right. So to find 4 factorial, it's 4 factorial. It's 4 times 3 factorial. And so it means you would have to find 3 factorial. And so to find 3 factorial, you would have to say 3 times 2 factorial. And to find 2 factorial, you would have to say 2 times 1 factorial. And finally, we know 1 factorial. It's 1. Okay? So that's the general idea. To solve the problem of factorial, we have to make the number smaller and smaller until we know 1 factorial. Okay, so to demonstrate this, I have a function named factorial, and we're going to pass it 4, and it will return the answer to me, which should be 24. So let me make my factorial function. Okay, and it accepts some integer n, and it returns the answer. Okay, so any recursive function has 2 components. It has a base case, meaning we know the answer right away. For example, we know that anything that is 1 or less, the factorial of that is 1. That's a base case. So if n less than or equal to 1, we know the answer is 1. So we'll just return 1. Now, if the answer is not 1, then it means we are in a non-base case. And what do we do in a non-base case? We make the input smaller. So for example, if I ask for 4 factorial, then this if will not execute. So I have to somehow say that the answer is actually 4 times 3 factorial. And how do I do that? Well, I will simply say I want to return n times the factorial of n minus 1. Notice I'm calling the function to help me solve the problem. Okay, so this function is named factorial, and I am calling this function inside the factorial function, and that's why we say it's recursive. It calls itself. Any function that calls itself is recursive. And so we will do exactly what happens here. Okay, so if I take a rough example, to find 4 factorial, then it means that we will have to say 4 times 3 factorial, right? Right here, 4 times 3 factorial. But we don't know 3 factorial. All we know is 1 factorial. And so we have to now find what is 3 factorial, which we don't know. We do know that it's 3 times 2 factorial. What is 2 factorial? We don't know. So we'll have to ask the function to help us, which we know is 2 times 1 factorial, which we do know. And so 1 factorial is is 1. So since I know 1 factorial is 1, I will just remove this and put 1. And since I know 2 factorial is 2 times 1, which gives me 2, then I'll just remove this and put 2. And then since I know 3 times 2 is 6, so 3 factorial is 6, well then I'll remove this and put 6. And then 6 times 4 is 24, so 4 factorial is 24. And so that is what I mean by a recursive function. Similar to the merge sort, where we had to just keep doing over and over and over until we get to a simple case, and then we go back up. Okay, so to show you how this works, I'll just run it. So go main, run, 24. Okay, now to give you another explanation, I'm going to open up my sketchpad and I'm going to draw it for you. So the key to recursive function is to always remember this. If you want to trace a recursive function to see how it works, whenever there's a function call, you need to draw a box. Okay, so this is what I'm going to do just to show you. So I have my main, right? And so main calls, right? So this is main. And so main calls factorial. Okay, factorial 4. So if I were to draw this, right, so I'll call, so result will be whatever factorial 4 gives me. Okay, so we make a function call. So whenever we make a function call, you draw a box underneath. Okay, and so we are calling the factorial function. And the factorial function expects a number, which we know is 4. So n is 4. Right? So notice we have left main. This is main. We've left main. And we are in the factorial function. And so factorial is isolated from main. Okay? Good. So even though we have 4 here, result here in main, factorial will not see those. Okay, so factorial is private. Every function is private. And so if I look at factorial, it says to check n. N is less than or equals to 1? No, n is 4. So I'm going to skip this. And so I will execute line 22. N times factorial n minus 1. So if I come here, I will have return 4 times factorial of, what is 4 minus 1? 3. Good. Now, this is where you have to remember. This is a function call. And I just told you a while ago, whenever you have a function call, what do? You draw a box. Now, we have left this factorial and we are now moving on to a new factorial. That new factorial will have n being 3, right? Because that's what you did. Notice this return is still waiting. So it's 4 times something. We don't know this something. And so n is 3. So again, this is a new factorial function. N is 3. 3 less than or equals to 1? No. So we're going to jump down here to line 22. And so line 22 says to return 3 times factorial of 2. We don't know factorial of 2, but guess what? This is another function call. And so whenever you make a function call, you draw a box. And so n here is 2. And so we're going to say return 2 times factorial of 1. 2 minus 1 is 1. Okay, so this is a function call, which means you draw a box. And so n is 1. And we know what 1 is. We know what it is. When n is 1, it's 1. So it means we don't get to line 22. We stay at line 19. So we return 1. Now, this is the key part. Remember, you will take this 1, and where do you put this 1? You put this 1 in place of the function call. So the function called, the answer is 1, because that's what was returned. And then this is now dead. So what is 2 times 1? That's 2. So you return 2. Who do you return 2 to? This one. 2. Okay. Okay, so of course this is dead. And so now it's 3 times 2, which is 6. And who do you return this 6 to? This F3. Okay. And of course this gets killed. You need the space, so you have to kill it. So 4 times 6 is 24. And where does this 24 get returned to? To main. Who called it? 24. Okay. So this is how you trace a recursive function. So always remember, whenever you're dealing, and it's not only recursive functions, when you're dealing with functions, you draw boxes to show that a function is being called. Okay? And please remember, even though I am calling factorial many times, each factorial is its own copy with its own value of n. Okay? So this first factorial has n4. The next factorial has n3, and so on. So each of these factorials are separate than any other. Alright? So that is a bit about recursive functions. Okay, I'll leave it here. That's it. We'll move on to our next topic, where we'll continue discussing the different tools that are provided to us to deal with concurrent programs. I'll see you in those.